I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Hey, it's me, Cowboy Rufus. I'm trying to get my hat and my head in this here triangle. But it doesn't seem to be big enough. Either my head and my hat's too big, or this triangle has too small of an area. So I know all about area of a triangle. So Professor Pi, he said I could talk to you about area of a triangle. The area of a triangle is 1/2 the base times the height. 1/2 the base times the height. If you heard cowboys say it, the area of a triangle is 1/2 the base times the height. The area of a triangle is 1/2 the base times the height. That's what you're going to need to know to find the area of a triangle. This is perimeter and area of a triangle. G.co.1, G.c.1, and G.gpe.6. We also find the area of a triangle in Algebra 1, Algebra 2, and we do it again in calculus, although in calculus our triangles are much more involved. It says I can calculate the area of a triangle. I can calculate the perimeter of a triangle. And I can find the missing base or missing height given the area of this triangle. My video goes there at the top. I've given you 3 others. If you don't get anything from my video, hit the other 3. Let's start with perimeter. Perimeter of a triangle. You add up side 1, side 2, side 3. There's really no formula for perimeter triangle, so I kind of made one here. How do you find the perimeter of a triangle? There is no formula for the perimeter of a triangle. Just add all 3 sides. Just add all 3 sides. Then let's go back up to area. Area equals 1/2 the base times the height. Area equals 1/2 the base times the height. That's the 6th time in this video you've heard that. And I've told you that memory involves 7. So I'm going to say it one more time. The area is 1/2 the base times the height. The height is also called the altitude in some books. It is the line from the vertex that's perpendicular with the base across from that vertex. Many times in your books, it'll be expressed as a dotted line. A triangle, it could be inside or outside the triangle or right down the triangle. This is a right angle. So this is the altitude in blue. The base is down here at the bottom in red. Now, this is still the base and this is still the altitude. If I turn that triangle on its side, if I turn it upside down, this is still the altitude. This is still the base. Most of the time, your base is going to be at the bottom of your triangle. But if we turn your triangle upside down, it's still a base. Here's an obtuse triangle. And its altitude is outside, completely outside, because it's got to be perpendicular with that base extended. Now, the base is the red part, not the added blue part. But the altitude is that blue part there. And in most of the time, you're going to see that the altitude goes right down the middle of the triangle and touches that base down there in a perpendicular distance. Many times in geometry, you will not be given the height. You will need to determine this height by properties of equilateral or isosceles triangles that we learned in chapters 2 and 3, the Pythagorean theorem that we learned in chapter 4, or the trigonometry that we learned in chapter 8. They may give you an angle and ask you to find the height. They may give you 2 of the 3 sides and ask you to find the height. But you'll need to use something that you've learned before. Well, just like in all math, if you can't do chapter 1 and 2 well, when we get to chapter 11, you can really get lost quick if you don't pay attention. Here's my first example. The altitude is on the side of the triangle. Let's let the base be 12 and the height be 7. It's 1/2 times 12 times 7, which is 84, times 1/2, which is 84 halves. 84 divided by 2 is 42. Example 2. Here they're going to give you the area and ask you to find the base. The area is 72 and the height is 6. So A equal 1/2 BH, and I'm going to put in what I know. When I put in what I know, I got to have one variable left, and the rest is numbers. That's the problem you've been able to work ever since pre-algebra. So 72 is equal to 1/2 base, and the height is 6. What's the opposite of 1/2? That is, what's the opposite divide by 2? That's right. That's right. Everybody in class knows that the opposite of divide by 2 is multiply by 2 on both sides. So I get 144 equals 6b. And now I got to ask yourself, what's the opposite of 6b? That is, how do we get rid of the 6? We divide, right? Well, we divide, right? Yeah, now the class knows it. 144 divided by 6, I think, is 24. Check my math on there because I might have done this when I wasn't thinking, and I don't think I used a calculator. Example 3 is a special case where they give you a triangle with no base, no height. They just give you 3 sides. It's not equilateral. It's not isosceles. It's not right. And the only time I've ever seen this triangle, by the way, is in math classes and on the ACT test. But we do have a formula that we've derived through calculus. And right now, I just want to show you the formula, but it works. I can't explain why until I get you a couple more math classes. But the area of special cases, the ACT usually puts one of these on there a year. The area of some triangle, you have no idea what it is. In my case, I'm going to choose an 8, 10, 14 triangle. I've already done the Pythagorean theorem on that. It is not a right triangle. S is equal to 1/2 of the sum of the sides. What do we call the sum of the sides? We call that perimeter. We take 1/2 the perimeter. In this case, we had 8, and 10 is 18, and 4 more would be 32, and half of that. So S, for our purposes, will be 16. S, the perimeter, times 1/2 is 16. So S is 16. Then we go up to this area formula here. 16 times 16 minus 10 times 16 minus 8 times 16 minus 14. That's 16 times 6 times 8 times 2, which is 1536. And that approximate square root is 39.6. And this is area, so we always have some units. I didn't put any units anywhere on this page. But you got to know what the units are. If you start off in centimeters and centimeters, you should have square centimeters. If you start off in yards and yards, you should have yards squared. If you're inches, you should have inches squared, because an inch times an inch is inches squared. Now, if your units are yards and inches, you can't do the problem till you convert one or the other. And I would convert the yard to inches because you all know that there's 36 inches in a yard. So I would make everything inches. If they give you inches and centimeters, you must convert. And remember, 2.54 cm is equal to 1 inch. We're going to do a little IXL. I'm going to work a couple more examples on the board. If you don't get it, go back and watch these other videos. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.